coming. Hello, all you 4 people that aren't here that said that half what? What'd I say? That's a Taylor Swift lyric. Oh my goodness. Okay, unpopular opinion. I do not like Taylor Swift. Popular opinion.
Taylor Swift is awful.
Did I not post it? When we're talking about rationals, we're talking about a fraction, okay? So that's what we're looking at. We're going to talk today about how to graph them and some discontinuities that happen when we. I know that happens. Oh my goodness.
Discontinuity. Oh, I never had.
Oh my gosh.
This graph will kill me.
So let's go through a couple of things. If I have actually, let's talk about vertical asymptotes. Let's talk about types of discontinuities first that happen. Yeah, but we're going to talk about how to find them now. Nobody. First kind. This is going to be. This is only whenever I'm in a fraction form. So something like x plus 1 over x squared minus 3x, I don't know, plus 4. And so that's what I'm talking about whenever I say discontinuity. What? I do, but I'm talking about specifically functions that look like this. Fractions. Fractions is what I'm talking about. All right, the first type of discontinuity that we're going to talk about are vertical asymptotes. We will talk about horizontal as well. All right, vertical asymptotes, where do those happen? Now, the key to rationals, just like when we were working with them algebraically, is going to be doing what? It starts with an F. Factoring. Factoring. That's going to be your key to see where things happen. All right, so for the discontinuities, vertical asymptotes always happen when the denominator equals 0, because remember that can't happen, right? Say right, because that's right. Okay, so when the bottom equals 0, that creates a vertical asymptote. Now there is one exception to that, and it's the second type of discontinuity. And the exception to that is a hole. And what happens is a hole is when the denominator equals 0 for a specific value, but it cancels out top and bottom. I'm going to write that for you and then show you. Factors cancel top and bottom. And it creates a hole. So let me show you. Let's say when I'm looking at the discontinuities here. Top going to 0 doesn't matter. I'm only worried about the bottom. Okay? So I know there's some type of discontinuity happening at x equals -3. Do you agree with me? I have to decide what type of discontinuity that is. Is it a hole or is it a vertical asymptote, and why? You're exactly right. If I factor the top here, I get x plus 5, nope, x minus 5. Right? These x plus 3's cancel out. Because they cancel out, what's happening is that it's creating a hole. Now remember what a hole is. I've got this whole thing going on, and then there's literally an empty spot on my graph for that one point. Because it canceled. Why did I cancel it out? Is that true? Because Okay, so x plus 3 going to 0, because remember, I'm looking at when the bottom equals 0. Yes, then you couldn't do it right. Does that make sense? Okay. So factoring is going to be the key. Let me walk you through, I think I'll walk through everything and then we'll just do a couple all together. Everything doesn't have a hole. The holes only happen when those factors cancel out. Okay, if the factors didn't cancel out and I'm in a situation like, let's say this one. Does that factor? Okay, make that negative for me. Now does it factor? Yeah. Minus 4 plus 1, right? It does still cancel, but something else is happening here. So at x equals negative 1, what do I have? A hole. But at x equals 4, what do I have? That's a vertical asymptote. See the difference? You set the bottom equal to 0, right? So I've got two things equal to 0. This goes to 0 and this goes to 0. But because this one cancels, it's creating a hole. Right. Right. Yes. You don't have to have a hole. You don't have to have an asymptote. You have to be able to look at it and tell what you have.
They're both discontinuous.
They're both different types of discontinuities. Yes. Yeah, same thing. Yeah, when it equals 0, it equals 0 when x is negative 1 or x is 4. Yes, yes. So if you've canceled everything out and it still sits in the bottom, so this would cancel out. I'd have 1 over x minus 4. That means x minus 4 equals 0. X equals 4. That's got to be a vertical asymptote. Yes, only in the bottom because I can't divide by 0, right? It creates something undefined if I divide by 0. No, it doesn't impact. We're going to use it for other stuff, but as far as discontinuities here, no, it doesn't do anything. Do you not believe me? Your calculator's not going to show holes, but it will show you vertical asymptotes. But you can go into the table, and if you put x equals negative 1, it'll give you an error message. We'll just wait for you to prove me right. Got a vertical asymptote at 4. All right. Those are discontinuities that way. Let's talk about, and we don't always consider horizontal asymptotes discontinuities anymore. It's also got a swing. We'll get to that. Don't you worry, my little friend. Yeah. Let's talk about horizontal asymptotes. Not necessarily considered a discontinuity anymore, but we'll talk about why that is. Right now, let me just show you how to find it. This is just a memorization trick. I'm going to teach you the easiest way that I know to do it. Now, when we do this, it needs to be in standard form, top and bottom. Before, so this is pre-factoring. We're going to look at the degrees of the top and bottom. Now, whenever I say degree, what do I mean? Close. The leading term, but it's the exponent on that, right? So the biggest exponent. We're going to have 3 scenarios it's going to tell me. The first scenario, If I am, I'm going to call it top heavy. In other words, the degree of the top is bigger than the degree of the bottom. Does that make sense by saying top heavy? All right. If I'm top heavy, I have no horizontal asymptote. So the degree of the top is bigger than the degree of the bottom. If I am bottom heavy, then y equals 0 is my horizontal asymptote. Y equals is a horizontal line, right? That means your asymptote, your horizontal asymptote sits straight, bless you, sits straight on the axis here. It's like this. And then that leaves me one more scenario. What do you think it is? They're the same. Balance. They're the same. If that's the case, this is the hardest one for students to wrap their brains around. It's y equals the leading coefficient of the top. What's the leading coefficient? That's the degree. The number in front is hooked to the degree term, right? It's the leading coefficient of the top divided by the leading coefficient of the bottom. So, for instance, if I had 2x cubed minus 7x plus 1 over x cubed plus 3. Right. I would have a horizontal asymptote at y equals 2. 2 divided by 1. That's exactly right. That's when they're the same. You wish that was all there was to it. Mm-hmm. All right. Just as a refresher, how do I find an x-intercept of a graph? Oh, okay, wait. It's coming from here. Yep. Set what equal to 0? You set the equation equal to 0, right? That's right. For x-intercepts, you set y equal to 0 and solve. And then for y-intercepts, you're going to set x equal to 0 and solve. Y'all ready to do one start to finish? What should we say? Yeah, but no, I'm not going to say something like that. But if somebody that's not here watches it, they'll tell him. I don't do this at home.
Actually, matter of fact, me and Addie were in the car the other day. We were listening because we were waiting for the argument. That was so hard. We were with our water. Was it a little bit? Oh yeah.
Yes, Logan, you have until what time do we start class? 12:05. 12:05 on Wednesday. To email me.
Hold on, Teresa.
No, a frog. A picture of a frog.
A picture of a frog, a tree frog.
If you do, you can.
On a window from the It's like the other side of
But they get specific things. All right, let's do an example. What time is it? In fact, let's do one from your homework sheet because it's all lined up there for you. You have 8, and I'm gonna do one with you. These look crazy, yeah. These look absolutely crazy. When you graph them, you'll see there's all kinds. They can look like this. They can look like, and we're not even getting into slant asymptotes yet. They can look like this. There is all kind of. It is. I didn't draw it as a function, but it is. Yeah, they kind of do look like that. It could do this. Okay, they can look all kinds of ways. So we're going to have to go through this step by step to figure out what is going on with our function, okay?
No, 13 reasons of why you should do it. This would be pretty self-love.
Which number did you say was it?
1 through.
Yeah, we'll do 8. Now, I'm going to tell you the method that I use to graph these that I think is the easiest to graph. I always go through. Don't want me to write this down. I always look for my horizontal asymptotes first because I need that not in factored form, right? I need that the way it sits now. So I always do horizontal asymptotes first. Then I factor and I look for vertical asymptotes and holes. Then I find at least 2 points on either side of my vertical asymptote so that I have enough to pick up a pattern. If there is none, then pick up another. You're going to use your calculator to help you with a lot of this, but I am going to make you do them by hand. So you're going to have specific points. So you can go into your table, you can go second graph and pick up the points that you need to. But graph it to see, you need enough to pick up the pattern. That must have been a wrong specific point. No. All right, here we go. Everything's standard form, top and bottom. So tell me what I know about horizontal asymptotes here. Bottom heavy. Bottom heavy means what? Y equals 0. So right off the bat, you can go over to the side where it asks you, see it says HA. That doesn't mean it's funny. Thank you, Miguel. I appreciate that. Y equals 0 is an asymptote. Okay? So I can go and put that, and for horizontal asymptote, I know Y equals 0. It's bottom heavy. Because the degree of the top is 1, the degree of the bottom is 3. Yep. That's all you look at for horizontal asymptote.
To pull out that.
You're looking at the degree. The degree is the biggest exponent up top compared to the biggest exponent in the bottom. No, because if it's top heavy, there's none. Y equals 0.
Whoa.
Y equals 0. It's an equation of a line.
I just realized.
But X equals 0 and Y equals 0 are two totally different lines. Okay. On we go. Let's factor everything completely. I can take an X out of the bottom, right? So I've got 4x times, or over x times x squared plus 2x minus 3. I can still factor a little bit further. Yep. First thing, does anything cancel? X cancels. Look at that. X in the top and the bottom. So that means I have a hole. Where is my hole? I've got a hole at x equals 0. It's not, because I'm multiplying, and this is just multiplying here. There's no addition. Okay, so no, because if you just set 1x equal to 0 and you divide by 1, it's still just 0. Yep. All right, so I got a hole at 0. Keep that in your brain. We'll use that in just a minute. Well, but you need the y that corresponds to it. How could I find the y? Because if I plug 0 in the way it sits originally, I'm going to get a 0 in the bottom, and I don't want to do that. So how could I find the y that goes with that? What happens when you put it in your calculator? Put it in your calculator, tell me what happens. It's a bit of a trick question, but go ahead. How can I find, I need to put this hole on my graph, and all I know is it happens when x equals 0, but how do I find the corresponding y that goes with it? If I graph it, that's okay, let Dozier do it so we can see. It should. You did not input it.
All right, and then next is.
There's nothing there. Look, it says x equals 0, y equals. You know what means? No. Okay, there's a way to do this, y'all. Let me just show you.
No, I think I know.
I'm going to cancel this out because it can cancel out. So now I have 4 over x plus 3, x minus 1. Now put 0 in for x and see what happens. See what we did there? To find the hole. Which means I have a hole. I canceled out where the hole was happening, right? So I canceled just the x out. And then I plugged in, you see where I got 0, right? I plugged that into the equation once I canceled it out. Well, 0 plus 3 is 3, and 0 minus 1 is negative 1. So 3 times negative 1, negative 3. All right, so 0, this is negative 1 1/3. 1 1/3. I'm going to put a hole there. Miguel, what's Dozier doing? You playing Pokemon?
Oh, exactly. Hey, let me
Keep an eye, Miguel. Keep an eye for me. All right. What's wrong? It is. So the point is 0, negative 4 over 3. Negative 4 over 3 is negative 1.333 repeating. So I went down 1 and then a little bit further. And a hole. Yep, it's a hole.
Now for the asymptote.
All right. Vertical asymptotes, where are they? Negative 3 and 1. How do you know that? That's what makes the bottom 0. So my vertical asymptotes are at -3 and +1. +1, 1, 2. I can hear that. Not during my class, Dozier. All right. What'd you say, Kate? I'm sorry. So you take what's in the bottom, right? And you take what didn't cancel out, which is the x plus 3x minus 1, and you set both of those to 0. It should be. All right. Everybody okay?
I don't understand why you put 0 in for the X.
Because I needed to know where it happened. So that's how you find where it happened. Whatever crosses out, you take what's left and you plug that value in. All right, here's where we're going to rely on our calculator. Well, actually, wait. Let's do y-intercept. Actually, there is no y-intercept.
There is no y-intercept. What are you saying?
It would make me be undefined. Let's take out the calculator. Take out the calculator. Take out the calculator and put this in. Make sure you do the top in parentheses and the bottom. Just ask about it. Okay.
Just like the whole beginning of the question?
Yeah.
Cucumber coins, little ice
What do you mean no
and
chips?
goldfish, yeah, there's a couple.
It looks like y'all got all the leftovers. What? You can plug in whichever you want. I usually go back to the way it was originally just in case I made a mistake. So I would do 4x divided by, these do not look normal. These look horrendous.
It's like,
Does it?
mine is not.
Make sure you got parentheses where you need. Do a zoom 6 on it when you graph.
I did absolutely nothing. My graph is exactly the same. Why? Do you just do the original?
I think mine's just the asymptote.
Some do and some don't, depending on your calculator. Let me show you what it should look like. Some calculators will do that, unfortunately. So you have to be able to interpret what you're looking at. Yeah. Come on. That's what mine looks like. This is a vertical asymptote. This is a vertical asymptote, and these are little wings on the end that do this with a little, looks like upside down parabola in the middle. Yours does what? Hold on just a second.
You put plus.
Did I do it wrong? Yes, that should go all the way up. Mine's an older calculator. All right, so what I'm going to use is I'm going to hit second graph, and I'm going to go into this table, and I'm going to pull my values from here, okay? Knowing what I know, and look at my error here whenever x is 0, right? Yes. And I'm just going to come in, and I'm going to go on either side of my vertical asymptote. So I'm going to kind of do this, just so you can see. 1, 2, 3. So I'm going to go -4, -5. I know I want those two. I know I want -1 and -2. I know. And you might have to even pick more than just this. And I'm going to go 2 and 3. I'm going to start with those and see what happens. So -4, I got 0.8. These don't have to be, you don't have to graph them exactly. I just need enough to pick up the pattern here. If you go into your calculator, does your calculator not let you type them in? It will. It will. Go second. It will. Go second window, which is table set. If you want to be able to just scroll through a list of numbers, change independent to auto, and it'll automatically let you scroll. I like to ask what I'm going to, I like to highlight ask so that I can type any value in so I don't have to scroll to find something. And so now whenever I go into my table, I can type any value I want without having to, scroll to another value. It doesn't matter which way you have it set. All right, so let me pull these values. Make sure you get the same values here. That thing makes my computer drag. -1, -1, -2, -1.3. 2 is 0.8. These are looking very familiar. 3 is 0.33. And so I'm just going to kind of graph these. -4, 4, -8, somewhere way down here. -5. Oh. Can't read my own writing. Negative. Okay. But that's bigger than the other, so it needs to be here and then like here. I need to just figure out which way is going up and where am I going down. I know I'm hugging the asymptote this way. I know I'm hugging the asymptote this way. So there's my first little piece. -1, -1, -2. So I'm doing something like this. Making sure to leave that hole out. There we go. Why is that not right? Yes. I have a hole. Your calculator does not handle holes well. It'll show you in a table that there's a hole there. It'll show you that there's an error message for that value, but it's going to look like a continuous graph because it has trouble leaving out simply one point. Why what? These stink sometimes. Some of them you'll get through and they'll be a breeze. They'll be nothing. I picked one of the hardest ones. We use it a lot in calculus.
Well, that's not the real world.
Not most of it is not by hand though. We'll use a lot of things like the asymptotes, the horizontal and vertical asymptotes, and their definitions. We use that a lot. All right, so domain here. Okay, where are you confused?
Domain.
What 0? Right here, just the hole. Because I plugged it in down here, remember? -infinity to, what, did y'all hear that? What was that? Did you make a noise?
No, that's probably.
No, it was louder than that. All right, -infinity, and then so I'm starting to the left, and I'm trucking until I get here, and there's a roadblock, right? What is that value? -3. Can it be -3? Yay or nay? No, so I'm going to do a parenthesis and a U. That's right. Then I pick back up at -3, and where's my next point, problem point? At 0, because of the hole. Don't forget that hole. So at 1, and then I pick back up from 1 to 0 to 1. And then, no, all of them. No, don't. Look, discontinuity, discontinuity, discontinuity. Those are what I'm leaving out. This is a vertical asymptote. This is a hole. And this is a vertical asymptote. All those have to be left out. That's why we found them.
Oh, of course.
Yeah. The range. Here's the problem with the range. Look at all of this area.
Oh.
I need to know how high up this goes. Does it?
There's always next one.
I don't believe you. I'm going to calculate
No,
it.
it is. Okay, Mr.
It
Dean,
is,
don't
because
worry.
-1 to -1
You literally
is the highest
We
calculated
have to
point.
leave out the 4 first.
The -1 to -1 is the highest point. And that's the
Never mind, no.
then -1 is that.
I got, what did y'all say it was?
-1.
Okay.
Oh, Mr. Gates, you have trusted your students.
That's included.
That's included because there's a point there. The point that's not included is the hole, but that's not the hole.
The whole number goes away.
I calculated it on my thing.
4/3 is
That's
definitely
covered by the hole is covered by the other hole.
-1 is here. -4/3 is here.
Exactly. So as you go from bottom to top.
You're talking about you want to leave the hole out? You don't, because on this side of the graph, it has a place there for the y. These are very, very confusing.
It's from 1 to 0.
And then from 1 to 0, that's right. So then I pick back up at 0, but it cannot be 0 this time.
That's definitely one.
No, there is no graph between -1 and 0. I have to skip to 0. Once I hit right here, I don't have any more graph until I get up here.
Even then you don't have graph.
So I left out all that space between -1 and 0.
Even then you don't have